In later classes, we'll be using web remote applications. Phil Donahue will be covering that. And for that, there's a node JavaScript that will be needed for that. But don't go ahead and get a hold of that, because it's a little premature. The version of JavaScript that works with web remote is not usually the latest one, and I don't think it's currently the latest one in 5.2. Phil will have better information about which version. They tend to want to give you their latest version, but we probably want to avoid what they call the LTS version, the long-term support version. I'm sorry, that is the one that we're probably using, but there'll be more about that later. And lastly, depending upon what your scene is, the one that you'll be transacting to a wall, may want to add support to sky atmosphere affecting fog height for a better look on the wall. And as Rebecca was saying, you typically, if you're having something like this, if you have something like this in your scene, you'll probably want to or need to add fog on your actual set so that it combines with what's going on in the wall behind it, so that there's to basically set illusion. So plugins for Unreal Engine that are used to get your scene up onto the wall. All of these plugins, and it's a giant list, are potentially necessary. It's a pretty comprehensive list, but you don't have to worry about turning these on, because if you're using the in-camera VFX template, the ones that you will need, for the most part, are already turned on, and that's really why we're choosing that template. The plugins are always there, but instead of having to go through this really extensive list, that's part of why that template exists. The plugins in white are enabled with the virtual production template, and the ones in orange are enabled with the NDisplay template. Additionally, and because we don't know what tracking system you'll be using, Rebecca mentioned several like Vive, OptiTrack, and there are others. You'll need to enable plugins for your particular tracking system. And
so this is our...
Sorry? You'll need to enable the plugins for your particular tracking system, and OptiTracks, for example, are available here. Consult with your tracking provider. These were the plugins, as Rebecca mentioned, that were used at the latte stage, Epic's Los Angeles Tactical Training and Education stage. Additional plugins for DMX, which are computer-controlled lights, VR and XR, can be enabled depending upon your production needs. So, some terminology. NDC stands for end display, and it's a naming convention also for the asset that we use to when adding the end display asset to a project. It's just a quick way of so that other people that are picking up your project or the VAD from which to which you may be returning your project for further revisions, they will understand what that is just by looking at the asset immediately. A cluster, and this is a window that's part of the end display config window editor. A cluster is a group of PCs or hosts used within the end display setup. Only one cluster can be created per end display config asset, but that cluster can have many different hosts. Each computer with its own IP address is a host, and there can be many of them, depending upon how the rest of your system is set up, how that wiring diagram has been configured. A host is a representation of a machine with a unique address. And viewport is a window into that 3D wall. Rebecca mentioned in her talk that that the whole thing is essentially a window into a 3D world. But in order to put that together, you need lots of different little windows that added together become this giant window. A frustum, there's an inner and outer frustum, which controls the viewable regions of the LED wall. The inner frustum is the camera's actual field of view, or FOV. And the outer frustum is everything outside the camera's view that provides lighting for the other elements, actors on the set, and for reflection, say in the case of Mandalorian, the main character is wearing a reflective helmet, and what's on the LED stage shows up in those reflections. And pixel processor is the hardware and software system that divides up your Unreal virtual world into the mosaics that it collects from the host PCs and divvies it up into the mosaics that end up on the wall. Okay. So the use of this technology is the one you're most familiar with and probably thinking about is film and television, but it's also used for architectural visualizations. It's used in live events, as has been mentioned. It's used by the military for simulation-based training like flight simulators and war theaters. And it's used in retail, actually in advertising. There have been ads that you may be familiar with that have been done in LED volumes, where by the end they may take it down and reveal the trick where in a particular ad, I'm recalling a McDonald's ad, it's just friends that are getting together, and the virtual environment peels away and we're just left with them still still friends just getting together, the human element. So it's being deployed in more and more ways. And it's becoming pretty interesting. So we saw this side of the end display window in an earlier slide. And this is most of the rest of the interface. We're missing details over here, which we don't need to see quite yet. But we're basically slowly moving into the tool. So, as I mentioned, it's essentially an asset, like any other asset in Unreal Engine. But this particular one is pretty comprehensive in what it does. It's not simply a mesh that sits there, receives light, shading, etc. It's a tool for connecting the Unreal world to the rest of the hardware and software that's going to put your wall, bring your virtual wall into what's kind of the real world. So on the top left here, where we add the components that will be used to define what aspects of the camera and the world will be sent to the pixel processors and through the rest of the system. There'll be a screen which isn't here at all, but it comes in with a default, and we're looking at another one as we go along. An X form or a transform for moving all of those screens and your end display camera. A default view origin, something that needs to be defined so that alignments can take place throughout the system. An ICVFX camera that I just mentioned that is used. You have a virtual camera in the end display config, which is connected essentially to the virtual camera in your Unreal Engine scene. And then the cluster nodes that were discussed earlier. After these configurations are set up, and the viewports noted here will be on display down here, as we'll see later. You can have multiple displays, and we'll start out with just one, and we'll look at the Lux stage. We'll try to build that out. And they have multiple displays, and they'll be set up in this world up here, and then the layout of those displays here. And all of it is managed by Switchboard once it's set up, what those communications are. Now, Switchboard is an external application. End display is an editor within, is an asset and an editor within Unreal Engine. But Switchboard is a separate application, runs independently of Unreal Engine. It's a Python application that manages communications and controls multiple remote devices, the other computers and processors, etc., that are used for transacting to a wall. And this is the interface for Switchboard. You can remotely stop and start Unreal Engine instances once you've told Switchboard what project it is that you'll be using and loading it in. It will launch it on its own once it's told to do so, and it will send that project to the rest of the system. And it also has built into it a take recorder, something that's available in Unreal Engine for recording a scene, and you can trigger a recording just within Switchboard, which is really helpful. If you're using source control like Perforce or any of the others, you can update what changes are made by calling out change lists, calling up change lists, I should say, within Unreal Engine, and it connects the main computer, the control computer that has the project on it, where the changes are taking place with Lifelink Face, with KPro, which is a digital recorder by Asia, with Shogun's. If you're using those, Shogun is an Atmos camera monitor, recorder, switcher, and sound devices. Actual sound devices and actually sound protocols are used for some of these communications between devices. It's just another channel that can be utilized. So Switchboard is managing those communications, but it cannot work and communicate with any other devices unless Switchboard Listener is launched on the host machine and all the other devices. And it's a tiny little thing, but communications simply don't exist without it. So in order for Switchboard to work, certain Python scripts have to be installed on the machine, and the first time you launch Switchboard, it will ask you to install the dependencies that it needs. And once that's installed, you can continue. It will produce a log indicating that those dependencies have been installed. And if there are any Python errors that occur, simply remove those dependencies and start again. And you should be good to go. So Switchboard Listener doesn't really require any dependencies. It uses what is native to Windows, and it's a C++ application that functions exactly as it appears. It listens over a TCP socket server on each device, and it sends and receives JSON messages that at Switchboard's direction. So, pro tip: after completing the installation of the dependencies, it will allow you to create a set of shortcuts for Switchboard's batch file and Switchboard Listener's executable at the location of your choice. Mostly it just dumps it on the desktop. And you can set up Listener so that it launches on login, or you can launch it yourself. I keep, as you will see, Switchboard and Switchboard Listener on my desktop in a folder, so that if there are any issues with it, I can launch them independently. And if it didn't do that, or you skip that step, you can find these applications at these locations if you've done the default install, and create the shortcuts yourself. Most importantly, Switchboard and Switchboard Listener must match the Unreal Engine version that the project was created in. Although I should say, if you update the project, as may be possible, a 5.1 project opened in 5.2 will ask you if you want to update it, and if you say yes, then you'd use the 5.2 Switchboard and Switchboard Listener to get those working. Here, okay. So with Switchboard ready for ICVFX, what happens now? Once the Switchboard dependencies are available, you can start building your in-display config. And once that's complete, we'll come back and create our Switchboard config. And maybe we'll just, let me exit this. And so as I mentioned, here's a folder that has Switchboard and Switchboard Listener. We're not ready for these yet, because they will ask us to, like what project are we going to be using, setting up. So I'm just going to put those away and just launch Unreal Engine from scratch. And everybody's seeing my cursor and the like.
Yes, we can see it.
Good. All right, so this is an older project. We're going to create a new project. Starting with, as I talked about earlier, a template. This is what shows up in the beginning. And we'll go to Film and Video Events and choose In-Camera Visual Effects. And as I said, that they haven't fixed that text. Maybe they will someday. Doesn't really matter. Choosing that, we'll have to put it in a project location. I keep my project location names really short so that when I'm working on other people's projects or my own projects where the nesting of names becomes extensive, I try to keep the names as short as possible so I don't get into any character limitations. So we'll call this ICVFX _ class. My typing is terrible, as you'll become aware. We'll call it 01. That name already exists. We'll call it 02. Okay. Options include ray tracing. Not a good idea for walls, and we'll talk about that in later classes. And starter content, something you can add later if necessary. We're not going to need it, and we'll hit create. And it will reopen. It'll take a moment to open this because one of the things that Unreal does, one of the reasons that Unreal does what it does, project is out of date, even though it's a template. I'm going to update it. Okay. So this is your basic setup. Yours might look a little different. It might look like that. Um, Starting with 5, I think, they made the content browser or content drawer something that is interactive. And by using the control spacebar, you can invoke it or send it away. And the really cool thing about that is that it's available in almost every editor. So you don't have to make various editors, material editor, mesh editor, etc. You don't have to make those available. You don't have to make them smaller so that you can get to the content browser. I tend to, because I've been using Unreal Engine for so long, I tend to like to be able to have access to it at all times. So to do that, I can dock it in the layout, as you saw when I first opened it, and that's what I'm going to do. I'm going to get rid of filters, which we don't need. Filters are really helpful for finding things quickly. I'm going to reset the filters by just sending them away. So we're in, this tells us what project we're in. And this tells us what level we're in. And this is that template. And it has, as we can see in the world outliner, it has an end display in camera config. It's in this folder. Actually, there are 2 end displays. Not quite sure why the second one is there, but it is there. We're using, I'm pretty sure, I think we're using the one on the left. We can right click and browse to asset, and that's the one that's been selected, highlighted. And we're just going to get rid of this. I mean, this is a nice thing to take apart to understand what's going on behind this LED wall, so to speak. There's a color calibrator and a time code generator, a time code clock, I mean. And we're just going to get rid of really everything but the color calibrator and the time clock. So there's a Cinecamera actor. We'll delete that. We're going to break references to do it. We'll get rid of a light card. So a light card is basically a way of putting on screen, just adding a light into a scene. We can see in the on the screen the use of this light card, and it's basically just a little like almost like a spot of light, not necessarily a spotlight, but a spot of light that contributes light to the scene of a specific color or temperature or location, and it can help in lighting what's outside the frustum. Yeah, we got rid of the camera, so I lost the frustum. But you'll see it as you'll see it again as we go along. I'm going to get rid of the light card and also the end display config. I'm basically cleaning the slate. And we'll also get rid of this text. We don't really need it. And hey. So outside of this folder, we'll leave this folder alone. You could set up everything that we just got rid of by dragging this into your world. But we're going to go up to content and create a new folder in which we'll do our work. So new folder, and we'll call it end display. And because we don't have an LED wall we'll do a sort of proof of concept version of NDisplay config, and I'll just do it using my own monitor, a home monitor. So we'll call this NDisplay home. And we'll double click on it. And add an NDisplay config, similar to the one that we just deleted. We'll do that by right-clicking and locating in this long list NDisplay. And in the NDisplay, among the NDisplay choices, there's only one. These often have many other choices, depending upon what it is. In animation, there are levels and sub-levels of things to choose from. But for NDisplay, there's only one so far. That may change as development continues. Now you can copy from an existing configuration, and we have two to choose from before making changes, or we can create a new config, which is what we'll do, from scratch. And as I mentioned earlier, we use a naming convention to make it really easy to for others to identify in your VAD or among other Unreal Engine people coming to your project. We use NDC as a naming convention because it's short and descriptive. And we'll call this, we'll just call it NDC home. And we'll double click to open it. And here's that interface that you've seen in slides. The stage on which the viewport essentially for our virtual world, our virtual screens, the layout for those screens, the cluster area, and what we didn't see is details. And to make this easier to see, I'll drag from the tab and park it next to the LED curved stage. Now you can see that in the background there's a sort of guide to help you understand the order in which things happen, should happen. And what we'll do at the start is we have some elements that are already in place. We have an NDisplay screen, and we'll use that because it's a reasonable default, and it's I think we'll see it's the right size. So we'll start to add things from the top left, and these two steps have add buttons. And this first add button will add a transform so that we can, as I mentioned earlier, move the whole configuration around. So NDisplay transform is added. And we'll rename it so that we know we created it. We'll call it XForm. And I'll make the screen, or representation of the screen, a child of XForm, so that if we move the XForm, it will go with it. Additionally, we'll add a camera into this in the NDisplay. So an ICVFX camera, and we'll rename the camera something to help us identify it. We'll call it home. or our home setup. And we'll make it just a child of the X form, not of the end display screen. You may have noticed that anything added becomes a child of whatever is selected in this step one list of components. So now we have a camera and we have a screen. And the screen is not showing us anything. The next thing to do is to set up the clusters to plug these elements together so that they see what's in our virtual world. And our virtual world here is this background of office buildings that are Epic Games headquarters in Cary, North Carolina. So to do that, we'll be setting up a cluster. And in cluster, the add button has only one choice for now. We'll add a new cluster node. And this is where we start to have to pay attention to other machines and other parts of the rest of the system. In the case of an LED volume with lots of computers, Rebecca mentioned in her talk that there has to be a network that supports all of those computers, and you can, for small setups, you can have sort of an individual router that's not associated with your, say, router, internet connected router for managing small networks or even complicated networks that you don't want to have outside interference with. And you'll need to know what the IP addresses are for all the devices within that network. And because we're really just going to be talking to ourselves here, and not any other machine or any other part of the network, we'll go with the 127.0.0.1, which is the local host address. It's a loopback interface, a top-level domain for the computer to talk to itself. And you can choose a starting size. In the case of, in my particular case, and possibly yours, I'm using a full HD monitor, and these are its dimensions. And so that's fine. We'll use that. None of this is going to, none of the rest of these options are going to matter at the moment, really, or for anything that we're doing today. And once we've added that, it adds that node from the host 127.0.0.1, and it adds a viewport to step 3. And I'm just zooming out to see it. And if we select that viewport, we only have one, but the next stage that we will be setting up has more than one. So it's a good practice to rename them so that you can easily identify, and others can easily identify what they are, where they are. So this is viewport 1, viewport 0, I should say, and we'll just call this, we'll call it home. I told you I couldn't type. There's more evidence. And that's its name. So now we will go to the details to tell this viewport how to behave, what to look at. And we'll do that in its details. So we want the viewport enabled, and we need to give it a view origin. And there is a default origin provided, which, depending upon your setup, may or may not be necessary. We'll choose the default viewport as a starting point. And we also need to tell it what's being projected to it. So in this case, what's being projected to it is what's behind here. And this is essentially this end display screen is a simple mesh, but it is a mesh. And so we'll set the projection policy to use a mesh. And which mesh should it use? Well, for now, the only one that's available is the end display screen. And once we do that, it starts to show us what's in our virtual environment. Pretty good. It's working. Additionally, we can show what the frustum and the size of the screen are the same, but we can, if we had a larger setup, we could show the frustum. We can do a search for frustum and preview the frustum, and by turning that on, we can see from the default viewpoint what that frustum is capturing. And we can see from the outlines of what it's capturing that it is matching what's on our screen. So that can be helpful when configuring your screens. I'm going to compile and save this. Sometimes I run into situations that crash. And I'm going to turn off the search, and we have our first end display config. So is everybody okay with what we've done so far? This will all be in the recording, so you can review it later. And you also have the slides. So to continue, the next thing we want to try to do is put this in our world. So having compiled and saved, I'll close this. And the best way to bring this into our world is to add a camera, create a level in which you add your end display config and an actor, a cinecamera actor that's in your that will be used in your Unreal Engine in your scene, in the level that you're transacting to a wall. So we'll create a level for setting that up, and we'll right-click in the content browser in the folder we created, and we'll create a new level. And we'll call it NDC_home level to avoid name confusion. And we'll hit enter. When we double click to open this, we'll see that it'll ask us if we want to save, and we'll say yes, we want to save. We've made changes to this level that we hadn't saved. This LED curve stage level, we haven't saved those. We don't want the things that we deleted, and so we will save its state. And now what we have is a level with no lights, no geometry, no nothing, completely empty. And before bringing our in-display config into this world, we'll change its view mode so that we'll be able to see something of the config that we created in the world. We'll set it to wireframe. And when we drag our in-display config into this world, we have a wireframe version of it. It looks like I turn the frustum off. It's showing the frustum. Let's go to our config, double click on it. Yeah, I didn't turn the frustum off. There's no reason it has to be off. It just looks better. And interestingly, it's not going to go off. Okay, well, we'll leave it on. If that's it might be that let's delete this and save in case we're going to encounter a crash. That's now the save state. Okay. So let's see if we drag it in again. Yeah, the frustum is still there. Okay, so we could rebuild it to get rid of it, but I won't bother doing that. So to know where this is in the world, in our level, we don't really have, we have coordinates for it, but they don't actually tell us anything useful. It's best to for alignment purposes, so that everything lines up, to zero this out. So we'll use the reset this property to its default value. We'll use that arrow, and it snaps to 0, 0, 0. And we know where it is because, whoops, I'm using the F key once it's selected to reframe it, to put it in the center. So this is our in-display camera. And what we want to do is add a camera to this so that when we bring it into our scene, we have a camera that will actually see that scene. The end display camera is just kind of a placeholder, a connector for other cameras that you can add. So using the cube with the drop-down arrow to add assets, we can go to cinematic and add cinecamera actor. And it's popped the camera into our world. We'll name it so that we know that we added it and what camera it is. I'll hit the where's it? F2 key and call it Cinecam Home. we'll zero it out so that it matches the location of our in-display config, and it will snap to the same location as the camera, as the in-display camera. Additionally, I will drag it on top of the in-display home so that it's parented, so that they all move, so that the Cinecam actor and the in-display camera are all move together, and the screen and the camera and that whole config moves together. Additionally, we'll go to in-display home, and in its components, among its components, that we added the X form, and we also added the ICVFX cam home, the config camera. And if we select that and go down in the details, we see that it's independent for now, but we can attach cameras to it so that they are connected and so that the information flows between cameras. So for Cinecam actor, thing that we added, we have none set, but we can use the drop down to find Cinecam home, the camera that we just added, and they're now connected. And now the in-display camera will use Cinecam home's information. So we'll save this, Control-Shift-S, and go back to our templates folder and go back to our curved stage, LED curved stage, which is now in wireframe because that's what we set our new level to. And we'll return from wireframe mode to lit. And we're back where we are. So now to add our in-display config and its camera into this level, the way to do that is to go to the levels panel, where we have a persistent level. If you don't have a level panel here, and I'm not sure that that comes up with the template or not, it can be added through window. You can find levels and select it. Get rid of it and start from scratch. Add level, and it's adding it in the place that it last occurred. If you're adding it new, it just might be in its own window like this, and you can drag the tab around to whatever location works best for you. In my case, it's next to Outliner. So we have two levels in our project, and we can tell that by going to the top level and adding a filter for levels. Actually, we have many levels in this. I forgot how many levels there were. We can turn this off, this filter. This is really handy. I use this all the time to find things. And we'll go to our, the level we want to do something with is our in-display home level. In the levels panel, next to Outliner, we'll go to levels and we'll add an existing level to our persistent level. And here we'll navigate to the one that we created in our in-display home folder, our in-display home level. And once we do that, once we pull that in, it appears on our stage, in our scene. The next thing that we need to do to get this to work is to change what type of a level it is in this levels panel. So there are two ways that a level can perform. It can perform as it does by default as a blueprint, the basic building block underneath all the other building blocks in Unreal Engine, or it can be set to stream, and that's what we want to do. So we'll go and right-click on our home level and change its streaming method from blueprint to always loaded, so that it's updating constantly. Any changes in the level will be updated immediately. And it will send that information to all the rest of the parts of the system. So now in Outliner, we have our end display home that's been added in Outliner, and our Cinecam home, our Cinecam actor that we added in our blank, what was a blank level. So we can grab this and pull it up. If we zoom in, we can see that it's moving our camera, it's moving our screen. We could choose the camera, and we rotate it. It's updating, it should be updating the screen. Look at this. In 27, post 127, and 20. Let's see if none changes it. Here we go. We had the default viewpoint was not our friend. And it might have been offset. It might have been messed up because of my saved change to the frustum. If I were trying to do a production, I'd just rebuild this end display config quickly to fix it so that I can get rid of the frustum rejection. But we'll carry on. I'm going to save everything. And let me see. Let's go back to the slides for a moment. So the next thing that we will need to set up to get our LED volume, i.e. home monitor, to work is a switchboard. Oh, let's see. Actually, this is a slide that Rebecca also used. So before we get to switchboard, I do want to talk about various geometries. How should we do this? No, actually, the best way is let's try to finish this home setup, and then we'll come back to this. So we'll come back to this to talk about setting up the meshes. So the next thing to do, the next step in getting this to work is to set up switchboard. And with switchboard and its dependencies installed and switchboard listener available, we would come to on the toolbar the little icon for switchboard. And this will launch switchboard. And at the top is take recorder, where we said we can basically record what we're doing in a scene and play it back. We can give the sequence a name or not. Well, I'll just call it scene, but actually I won't bother with it. And we need to actually create an entirely new, this is picking up an older session. So to create a new one, we come to config and we create a new config. And here is where we give it the essential information about the project and what parts of the project it will be using to communicate with other devices. And you can start, as I mentioned, you can start, it's a freestanding application. You can start it without any information at all, but it's really helpful to start switchboard from within the project that you're trying to transact, because it will populate the config with information that is needed without you having to do as much typing, without having to go to say on the D drive, go here, that kind of stuff. And if these come up blank, you can ask it to detect what it should be using, and it will try to populate these fields, config path, project and engine directory, with the right information. If it doesn't, you can always do it manually, but it's much quicker to do it from within the project. If you're using source control, like Perforce, you can tick it on and see if it detects that as well. So all of this is right, and we'll say okay. Once we do that, everything else in this window, in the window behind it, I should say, will sort of blank out, and we're starting from scratch. So it knows what project we're using, and it knows what engine we're using. It doesn't know what level we're using, and as we saw, we have a lot of different levels, and we need to tell it what level we're using. And we're using the one that we created, NDC home level. No, I'm sorry, we're using the curved stage. The home level has nothing in it. The curved stage has what we want to transact to our wall, and we want what's in this screen on our LED wall. And so, as we saw in the NDC config, there are devices that need to be added to enable communications. So the first thing that we'll do is we'll add, for our purposes, Unreal Engine, the engine itself, and we'll call this the device, the machine on which the project resides, where changes can take place that will ripple throughout the system. We'll call this controller. And we need to know its IP address, which is 1.2. 127.0.0.1, that high-level domain loop. And once we say OK, it adds that device, so to speak, into its list. Unreal Engine, control, and it has an address. If that address is wrong, it can be edited from here. It's selectable and editable. Excuse me, I just need to take a quick drink. A little moisture. And the next device that we need to add is our end display. And sometimes it will come up with the right end display just from the start. You can ask it to populate and it will go to the first one that's available. Sometimes that's the right one, sometimes it's not. If it isn't, you can use a drop-down list to find others. And if that doesn't work, you can browse through your project. But NDC Home was in everything that we created today, so that's the right one. And once we add that, it continues to fill out the log, and this is helpful in troubleshooting. Everything that you see in this log should be blue or white. If you're seeing lines that are yellow or red, that is an indication of a problem. Additionally, the console has all of the information that's being utilized to make these transactions work. There's a slide about this that we haven't seen yet, and I'll point it out as we go there, as we get back to the slides. Lastly, this is communicating. Oh, I'm forgetting one thing that's very important. Actually, let's go back to Unreal. So we've launched Switchboard, but as I mentioned earlier, in order for these communications to take place, even though it's such a tiny little thing, you need to launch Switchboard Listener. Switchboard Listener is tiny, but without those JSON messages, nothing will take place. So once we launch it, there'll be a little blip and it goes away. And not showing up on my main screen that you're seeing, but if I go to a taskbar, I can check on it to see that it's running. And it's basically just a command prompt window. And it is listening. It's doing what we want it to do, what we need it to do. And I just quit it. Don't ever quit it. There it is again. Check to see that it's running, and don't quit it, but minimize it. This is great. If I make all the mistakes, maybe you won't. And if we go back to Switchboard, we have Switchboard running and we have Listener running. To connect all of these computers, we have to use what's at the bottom left of the window, multi-user server. And whenever you set this up and try to put a session in motion, you want to ensure that that the multi-user server session is refreshed, is new. If you quit any part of the project and then come back to this, you really need to refresh this to ensure that communications take place properly. You can give this any name you want. Usually it'll have a project name or a stage name, other descriptors to help you know, to help you and others understand what it is that you're doing. Once you've set a name for this, multi-user session is fine for now. You want to iterate it. You want to sort of refresh it. And the simplest way to do it, you could do it manually, or you could do it just by hitting this plus sign at the end of the edit line. And it'll go from 7 in my case to 8. Cool. So you need to plug things together and then launch the project. Plugging together is done with these little plugs. Oh, here's where change lists take place. And you can toggle for to join multi-server, multi-user server or not. Auto join should be on by default. I would leave it that way, much better. We'll talk about this in another class, not today. Syncing devices after completion, all this should be fine. This top plug can be used to control, say, all the other plugs, but we'll do this individually. We'll plug the version of Unreal Engine in, and once we connect those plugs, we get a blue dot here indicating that everything is good. We see that the log is connecting and that it's received the information that it expects to. So that's good. And we'll plug in our end display device setup and we'll see if that's working. And it is, and it's color coded the console. And all of that is good. And we see the top plug, everything is connected. So I'm just going to, what am I going to do? I'm going to pull this down. We're trying to transact to the wall. And I could actually quit this and let Switchboard launch the project again. But I'll just try to make it a different aspect ratio so that when Switchboard does launch Unreal Engine, I can distinguish between the project we started with and Switchboard's iteration of Unreal Engine. And it's these up arrows that turn the whole thing on. And what we should see is Unreal Engine quitting back here and the screen going blank as Switchboard now takes over control of the computer and of our LED monitor, i.e. LED screen, i.e. my monitor. And then we should see what was in that little NDC screen. Oh, one thing that I probably messed up. We'll see if I did or not. Forgot to check the settings. Yeah, but it might have worked. Attempting a connection, and I think it did. I think it worked. We'll see. So this is the new iteration, the Switchboard iteration of Unreal that it used. And if we go to Outliner and go to our camera, will it update or not? It's not. It is in the preview. but it's not on the screen. And it may be because of let's go back to end display and quit this. See if we can't fix it or not. It's doing almost everything right, but one thing I didn't check, and one should always check, are the settings. We've made all of these choices here. Let's look at the settings. The settings basically, and there's only one option, the settings basically show us everything that has been added to this iteration of switchboard. One thing I was looking for was to see that the switchboard IP address is the same as the machine. Sometimes it isn't. You can see from this drop-down list, there are other ways of connecting. But this is the one that should work. Additionally, this all looks right. It's what we saw earlier. The endpoints look good. EX12, all good, all good. The node address is 127.0.0.1. Buffer size is good. Okay, all of this looks good. One thing that can be an issue, this came out correctly today, often it doesn't. The number of GPUs that you have. I only have one. Depending upon what your setup is, you may have more than one. You can have up to like 16. This used to be a 10. But this is set properly. So it should be good. Let's see if we can quickly troubleshoot it. We can't. We'll move on to, this is 11:30. What time do we end? We end in a half an hour.
Yeah, we go till around 12 and then it's Q&A after that for an hour.
Right. Okay, so I might have, there's a lot more information to go through, but this was a problem that let's try tearing this down and building it from scratch really quickly. New config. We'll call it NDC 1. Screen, good. We'll add form, we'll call it X form. We'll add camera. Home one. Make this a child of the X form. We have those two. We'll set up our clusters. .27 is the right address. We'll just leave this at the default name. Try the default viewport, which should work. It did last time. We'll set our mesh to be the end display screen. This is giving us what we want. Good. We'll compile and save. We'll close this. Create a new blank level in the level 1. What did I do? Oh, don't know how to type. We'll save this, sure, why not? Put this to wireframe so that we can actually see something. Now, there's no saved weirdness. 0. Oops. Add a camera. One. Connect it to NDC camera. Save the level. Go back to our stage. Turn off the streaming here. Hide it. And we'll add an existing level of level 1. See if that's any better. Here's 1. Camera. Oh, it did. Hmm. Weird. Oh, center. But I not. But I didn't zero the camera out. I did. Here's the offset. Okay. Is this functional? Let's find out. It might be that's weird, but it might be the view the view origin again. So I would have to build this from scratch, I think, to get it to work properly. Maybe during Q&A, I'll try to circle back to this to get it to work throughout the system. My apologies for that. We did see that it was transacting to the wall. And that this change in position is actually something that we just saw, but wasn't updating properly because connections. There's a couple of, it looks like, and I didn't reiterate here, but it looks like it did make that connection. My machine is lagging, so it's definitely struggling. There's a lot going on here. But this is the idea. All right, so to carry on, let's quit this session with the X at the top. And go back to Unreal. And go back to these slides, actually. So in this particular setup, a single monitor was the entire stage. But that's not what you'll normally do. Although there are plenty of stages out there that have a single single wall and multiple walls. But we'll look at another setup that has multiple walls. The latte stage was something that you saw earlier, which has a wide wall and a square wall. And actually there's something called a while wall, which is something that is just movable. It's on wheels. And the mapping for this is done. The latte stage is using a Brompton processor with Tessera software. And this is what the screens look like on the Tessera software, which manages the connections among all of the wires connecting all of the LED panels. The wiring, say, will begin at the bottom left of A1, actually, I think it begins at the top, goes down, goes up A2, over to other side of A2, A3, like this. And a similar pattern for the wide wall. So this is the square wall and the wide wall. We're not seeing some of the other, not seeing the wild wall. And the Brompton processor will take the information from that's fed to it and divide it up so that it goes to the proper mosaic. So here's the pixel processor. And this is a representation on the render CPU, which is one of the devices, one of the machines that Switchboard will communicate with. And this is the NDC configuration of those screens with these images of Epic's headquarters. And we saw this red outline for our single viewport. But with multiple screens, you usually need more space. And so this is one screen, this is another screen, and this is kind of like your work area. So to get this to work, you need to have meshes that represent your walls available in Unreal Engine so that they can be added to the NDC and be in the right configuration so that, for example, these two walls touch each other at the seam. And basically so that when your viewport goes, when your camera frustum goes from one screen to another, it doesn't get hung at the seam, or there's no misalignment. Because that's really what this entire thing is about. It's trying to get alignments correct so that parallax within your virtual world and your real world, the actors and props in front of it all align properly, so that the viewer can't tell that they're looking at a wall, that there's nothing there, that it isn't a green screen. It's better alignment. And to get these meshes to map properly, they rely on the UVs for these meshes. And so the UVs have to be set up properly for the pixel processor to map it to the right tile. And there are typically 2 UV channels for these meshes. Meshes, hard word for me, I don't know why. The UV 0 covers the entire 0 to 1 space. And if they're stretching, that's okay. You don't want, stretching is fine because you want to make sure that there are no seams in UV 0. And in UV 1, you have the entire geometry so that the seams will connect with one another. On a more complex stage, similar to, well, this is an ant, but it's moving in that direction. You have, this wall is so large that it has to be divided into 2 parts. And this does have a wild wall in this setup. And a wild wall basically means something that can be moved. This will be on wheels, and it's really just providing light from the Unreal environment to the set. It's never in camera. It's never part of the frustum, and it lights it lights the actors and just adds ambient light, or it could be used as a DMX light, as any kind of additional light or light card. So ceiling panels won't always have just right angles. There's sort of a curvature in the way these tiles are set up. Oops. It's reflected in the UV1. And these are all UV zeros. And so they have to go from 0 to 1 to get as much coverage as possible. And so we have, this is kind of the best example. The ceiling is essentially a T. You have these panels here, and by the time it reaches the end of that node, that connector, that wiring, it extends out on the sides, as we see here. And it has to meet up with this kind of apron, has to meet up with this edge of ceiling 1, the purple. In UV1, we see exactly that taking place. We see where the seams are. This apron meeting the seam of ceiling 1. And the two parts of the main wall meeting with no overlap. Wile walls don't need a second channel because they're not meeting anything. They're just adding light. The Lux stage is set this way. It has ceilings. It has 2 ceiling panels and a divided front wall. And as we saw from the prior slide, these are not the same size. They're not. It's not split in the middle, and this is often the case. Depends upon what the load is of the various nodes. And it's true also for the Lux stage. They're not exactly the same size, but they're pretty close. And there's a left and a right wall, and these are all fixed. In order to get this to set up properly, you need to know the dimensions of the wall and the tile layout, and you want your UV maps to match what the tile layout, so that the front wall on the left is 6 by 6 tiles, whereas on the right it's 8 by 6 tiles, and they have slightly different dimensions. And you need to know all this when you're setting it up. Sidewalls are also not exactly the same, but they're pretty close. And the ceiling is the least important, and so it has the lowest resolution, 640 instead of 1056. You're almost never, this production anyway, is not going to be shooting the ceiling. There are some that do, and you'd need a higher resolution for those. But this particular stage and this particular production, not necessary. Okay, so we created a config. And these are the steps that we took, some of which we violated. But what I'd like to do is show you how to build out the stage. So here's a one display setup and a more than one, and we'll be doing that. Let's do that. So let's see, we'll create a new folder and we'll call it Lux Stage. That's not a folder. We're actually not going to get this far. We just need a folder. And for our Lux stage, we'll need end display config, and we'll create a new one. And we'll call it NBC_Lux. And double click to open it, mark it. And they have multiple screens and not small ones. And so we'll delete this end display screen because it's not going to work for us. We have to use different geometry. We have to use a geometry of the Lux stage. And I'll add a transform to start with, because it's always good to have that. And now we need to find their geometry, and they gave us their geometry. I'm going to quit switchboard. We don't need it for now. And in my folder of LED message, I have Lux LA. And this little file contains all of the meshes that they use that comprise their stage. And if we go to our Lux stage folder, we can drag the geometry in and it will import. And on import, we want to reset to default so that we're not carrying over any of the attributes of other imports. If we brought in metahumans or something from a different project, we don't want those settings. We want to start from scratch. So reset to default. The only thing that we need to be aware of here is we don't want it to generate light maps, because doing so will change the UVs. And the UVs, as we've seen from the slides, are important. And it's not a transform, it's a material. Or it's in mesh. We don't want it to generate light map UVs. And we'll import all. And we might get an error message. Not important. Double click. And so we have various pretty simple meshes. It's too small. And we need to look at these meshes. So we'll look at ceiling 1 to start with. By double clicking, it opens the mesh editor. And the ceiling is over here. And we need to, it will have 2 UV channels. We can look at them to see what it is they cover. UV0 is covering the entire space, as we talked about. And UV1 is covering the UVs in the space in which it will be used. It'll be meeting up with another set of UVs elsewhere. For each of these, I'm going to just turn these off. And that'll be true for all of the other geometry that we bring in. One thing we need to do for each of these meshes is we need to make sure that it's going to use the UVs with precision. And so we need to turn on, under LODs, use full precision UVs so that it tracks properly. We can save this, but for some reason in 2.5, it doesn't seem to remember that. And it will always ask you to save. Close this for now. Next, we'll use ceiling 2. precision UVs. We can just close it because it's going to ask us to save. One of the quirks in 5.2, as I mentioned, is it doesn't actually do what you tell it to in that regard. Front one, precision UV. Two, left screen, which here is kind of square. And that's it, right? Yeah, that's it. Okay, so now with all of these, we've looked through the, we looked through all the UVs, presumably, and they're fine. And we can go back to our NDC and make it large. And if we bring up the browser, you'd think that with the add button, you'd be able to find the geometry that you need to add, but it doesn't actually show up. So the way to bring it in is to locate it in the browser, and I did Control Spacebar to bring it up, and we can add all of the geometry, 6 panels, and just bring it in, drag it into step 1. And if we zoom out and rotate it, these are all single-sided walls. We see the Lux stage. The front wall in 2 parts. They're not exactly square. The left screen, the right screen. Ceiling 1, which is closest to the large wall, and ceiling 2, which is at the front of the stage. So, if we look at, they have set up their stage with 3 nodes. And I can post I'll put the, somebody's asking in Slack for the geometry. I'll put it in Slack. Okay. I'll put it in Slack in a bit. So they've set it up so that there are, we saw on the latte stage that there was a main stage wall and a secondary one. And we'll be doing something like that here, except that there are 3 nodes, not just 2. We saw 2 at the latte stage. Here there will be 3. So we'll add a new cluster node. To give us workspace, we'll go with Ultra HD. And first node, and we'll we'll add our walls. Let's see, we'll add, we'll call this Lux front, front 1 underscore VP. And on the slides that you have are the measurements for them. So for Lux front, we need to change the dimensions, the region dimensions, to fit what what's used by the stage, by their processors. And the front left one is front 1 is 1056. It's square by 1056. And it's using for the projection policy, it's using a mesh, and that mesh is front 1. This node is using another viewport, and so we'll just duplicate the one that we have here and rename it front 2. And it's so front 2, front right has a slightly different, it is 1056, but it's wider on the left. It's 1408. And change its position to 56 so that it's over. Drag that over and assign it to the right mesh. And now we're starting to fill it in. That's our first node. Our second node is we have to add a second host. We'll also make it Ultra HD, and it needs a different address, otherwise it will clash with the other one. So we're starting our network. So we'll just make it 2. And it comes with a viewport, and we'll make this viewport Lux left. And they're calling it left 1, so we'll call it left 1. And it's using a mesh for its projection policy, and it's left 1. And its dimensions, the left one is 1408 by 1056. And we see it's active, functional. Weird that it's acting funky today, the view origin. We'll duplicate this viewport and rename it so that it is right one. And it's square, B6. And we'll move it over to 1056 to start with so that we can grab it and drag it over. Change, it's using a mesh, but we'll assign it the right one. And now it's mapping right. Wait a minute. Screen left. Screen right. There's something funky going on with the view origin today. And lastly, we'll add another node for the ceiling. Ultra HD and next address. And the ceilings, as we said, are really the lowest resolution. Lux ceiling 1. And the ceilings are the same. They are 1600 by 640. Mesh. Ceiling 1. Butts up against the wall. We'll duplicate that to fill in the last piece. We'll move it over 1600. And assign it. There we go. Okay. Compile and save. And this can be used by switchboard and the machines that are connected. Once you get the IP addresses right. They're wrong. And really, you should be using the same origin point in all cases. That could be a problem. And it's, yeah, none. All. Let's set them all to default. Default should work. Most of the time it does. Today, not so friendly. So, how is everybody doing with all this?